Let's look at the method of undetermined coefficients, that is the superposition approach, for polynomials. We're dealing with linear, second-order, non-homogeneous differential equations. So our differential equation will be of the form y double prime plus p of t y prime plus q of t y equals g of t. This is non-homogeneous because g of t is not 0. Okay, let's say g of t is a polynomial. Here's an example. Find a particular solution of y double prime plus 3y prime plus 4y equals 3t plus 2. The derivatives are polynomials. In other words, when we add the second derivative and 3 times the first derivative and 4 times the original function, we get a polynomial. So we suspect that y sub p is a polynomial. Our first guess is going to be y sub p equals at plus b. The right side, 3t plus 2, is a first-degree polynomial, so we suspect that y sub p is a first-degree polynomial. Let's just say y equals at plus b. That's our guess for y. Let's figure out what a and b are. Y prime equals a, y double prime is 0. Let's plug in all of this into our differential equation. Y double prime plus 3y prime plus 4y equals 3t plus 2. We end up with 0 plus 3a plus 4 times at plus b equals 3t plus 2. Let's multiply it out and get 3a plus 4at plus 4b equals 3t plus 2. When we group like terms, we get 4at plus 3a plus 4b equals 3t plus 2. So we recopied that up here. Let's compare coefficients. The coefficient of t on the left side is 4a. The coefficient of t on the right side is 3, so that means 4a equals 3. In other words, a equals 3/4. The constant coefficient on the left is 3a plus 4b. The constant coefficient on the right is 2, so that means 3a plus 4b equals 2. But we know that a equals 3/4, so let's plug that in here. We get 3 times 3/4 plus 4b equals 2. In other words, 9/4 plus 4b equals 2, so 4b is 2 minus 9/4. In other words, 4b equals negative 1/4, so b equals negative 1/16. Okay, so we have a equals 3/4, b equals negative 1/16. We knew y was of the form at plus b, or we suspected it, and so we can plug in a equals 3/4, b equals negative 1/16 to find that y sub p, a particular solution to this differential equation, is 3/4 t minus 1/16. Now let's find a general solution of y double prime plus 3y prime plus 4y equals 3t plus 2. The general solution of this differential equation will be y equals y sub p plus y sub h. Y sub p is one particular solution to the non-homogeneous differential equation we have above, and y sub h is the general solution to the corresponding homogeneous differential equation, y double prime plus 3y prime plus 4y equals 0. We know how to solve something like this, okay? We write r squared plus 3r plus 4 equals 0. This doesn't factor, so we need to use the quadratic formula. When we do that, we end up with r equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times 4 all over 2. What's under the square root sign is just going to be 9 minus 16. So we have negative 3 plus or minus root negative 7 all over 2. In other words, negative 3 plus or minus I root 7 over 2, or negative 3 halves plus or minus I root 7 over 2. So there's our value of r. Now in general, we've seen before that if r equals a plus or minus bi, then y is going to be c1 e to the at cosine bt plus c2 e to the at sine bt. So let's plug those values in. R in this case is negative 3 halves plus I root 7 over 2. So this is our a, and our b is root 7 over 2. Let's plug everything in, and we end up with y equals c1 e to the negative 3t over 2 cosine t root 7 over 2 plus c2 e to the negative 3t over 2 sine t root 7 over 2. So that's y sub h. That's our solution of the homogeneous differential equation, our general solution. The solution to the non-homogeneous differential equation will be y equals y sub p plus y sub h. In other words, it's the particular solution, 3/4 t minus 1/16, plus the general solution to the homogeneous differential equation, c1 e to the negative 3t over 2 cosine t root 7 over 2 plus c2 e to the negative 3t over 2 sine t root 7 over 2. Now, this chart may be helpful for finding a particular solution y of p. Here's how to find a particular solution y sub p for a differential equation of the form ay double prime plus by prime plus cy equals g of t. When g of t is of this form on the left, try letting y be a linear combination of g of t and its derivatives. For example, if g of t, what's on the right side is a e to the rt, then try using this for your y sub p, capital A e to the rt. If you have g of t as an nth degree polynomial, then try letting y sub p be an nth degree polynomial. Not the same polynomial, but just some other nth degree polynomial. And these other principles may help you too. You may want to take a screenshot of this. And if for some reason that does not work, multiply your guess for y sub p by t. And if that does not work, multiply your guess for y sub p by t squared. And if that does not work, multiply your guess for y sub p by t cubed, and so on. Here's an example. Find a general solution of y double prime plus 4y prime plus 3y equals 10 e to the negative t. The general solution, again, is going to be y sub p plus y sub h. It's a particular solution to the non-homogeneous plus the general solution of the homogeneous equation. So we saw earlier the solution of the homogeneous equation is going to be c1 e to the negative t plus c2 e to the negative 3t. We saw that in a different video. So let's find a particular solution to the differential equation y double prime plus 4y prime plus 3y equals 10 e to the negative t. That's the non-homogeneous differential equation. The right side is 10 e to the negative t, so we're going to try y sub p. A particular solution is a e to the negative t. Okay, so we have y a e to the negative t, y prime is negative a e to the negative t, and y double prime is a e to the negative t. Plug all of that into our differential equation, and we end up with y double prime, that's a e to the negative t, plus 4y prime, that's 4 times y, negative a e to the negative t, plus 3 times y, 3a e to the negative t equals 10 e to the negative t. So, we just rewrite when we rewrite all of this stuff, we end up with a e to the negative t minus 4a e to the negative t plus 3a e to the negative t equals 10 e to the negative t. Ooh, everything on the left side cancels. We have 0a e to the negative t equals 10 e to the negative t. Cancel the e to the negative t's, and we have 0a equals 10. Gee, I don't think that has a solution. There's no solution to this. It does not work. So we multiply our guess for y sub p by t. Earlier we tried a e to the negative t. Now we're going to try y equals at e to the negative t. Okay, so here's our differential equation, non-homogeneous. Try y equals at to the negative t. This is what we get for y prime after we use the product rule. At negative e to the negative t plus e to the negative t times a. That's just at e to the negative t plus a e to the negative t. Take the second derivative, again using product rule, negative at negative e to the negative t plus e to the negative t negative a minus a e to the negative t. That simplifies to at e to the negative t minus 2a e to the negative t. Plug all of that stuff into the differential equation, and here's what we get. Y double prime, which is at e to the negative t minus 2a e to the negative t, plus 4y prime, that's 4 times negative at e to the negative t, plus a e to the negative t, plus 3y, that's 3 times at e to the negative t, equals 10 e to the negative t. So you multiply everything out, you get the next line here, and then you group like terms. So there's a lot of stuff that cancels out. So basically all the at e to the negative t terms cancel out. And we're left with negative 2a e to the negative t plus 4a e to the negative t is 10 e to the negative t. In other words, 2a e to the negative t is 10 e to the negative t. Cancel the e to the negative t's and we get 2a equals 10. In other words, a equals 5. So if a equals 5, that means y sub p, our solution is going to be 5t e to the negative t. And that means the general solution of this differential equation is y sub p plus y sub h. Here's y sub a, or y sub p, I should say, our particular solution, 5t e to the negative t. And there's y sub h. That's just our general solution to the homogeneous differential equation.